Okay, this is Mr. Anderson for Math 130, Statistics. And today we're going to be looking at sections 3.3 and 3.4, talking about the measures of position, which is really going to be talking about variation. And in the previous video, we talked about the measures of position in terms of standard deviation. And that's where we're going to kind of pick up this. This measure of variation is called a z-score. A z-score tells you how many deviations you are away from the norm. For example, if you are very normal, your z-score would be 0 or close to 0. If you were 1 or 2 standard deviations away from the norm, that would be a good thing if you're looking for a positive number. But we want positive numbers because if we're not doing so well, then we'd have negative numbers. So generally, z-scores are between -2 and +2, but could go higher if there is an extreme case. But remember, this is with symmetric data, so it's most likely you're going to be between 0 to 1, or close to it. Now, to find a z-score, you're going to take the value that you want to look at and subtract the average from it. And then divide that difference by the standard deviation, whatever you found that was. And that is the formula written out. Take your value, subtract your average, divide it by standard deviation. Now, another way to look at it is to take that value, subtract the average of all the values, and divide it by S. Now, if you're looking at a population, you would take that person, subtract it by the average population, which is mu, and then divide it by the standard deviation of that population. Okay, so here's an example. A student scored 85 in a class that had a mean of 78 and a standard deviation of 12. So his score was 85, the average was 78, and the standard deviation was 12. If we compute that out, we get an answer of 0.6. Now, here's another part of this story problem, but it's a different class. A student also earned 90 in a class that had a mean of 86. So you can see that these scores that we're comparing are higher than the average. And the standard deviation was a little bit smaller. The class wasn't as varied. The standard deviation was 10. And that makes an answer of 0.4. So we can say that his relative position in the class is higher here than it was here. He was closer to being 1 standard deviation away, closer to 12, than he was over here, closer to 10. So his relative position was higher. Now, here's another example, kind of written a little differently. We're going to compare some quizzes. This is someone's 30-point quiz out of 42 average. That's not the total. This is the average number of points in the class. And the standard deviation in this class was 7. And we're going to take a look at another quiz, which was he earned or she earned 61 points. The average was 75. So we're looking at somebody who's performing below the norm. And the standard deviation was 12. So, if you pause the video here and compute those, when you unpause it, you will see the answers. The answer is -1.7. He was almost 2 standard deviations below the norm. And here is -1.2. He was a little over 1 standard deviation below the norm. So his relative position on this test was lower than on this test. All right, well, that's going to end our talk about standard deviations. In the previous video, we had talked about how to find standard deviations and what they mean, but I also mentioned that if you're not dealing with a data that's very symmetric, you should probably go to box and whisker plots, and that is dealt with percentiles. A percentile divides the distribution into 100 groups, or 100%. And how you would find a percentile is you would take your number of values below the score, or in this case x, and then when you count up all the numbers below that value, you're going to add 0.5 to that, and then divide by your total, or n. N is the count, how many pieces of data you have. So the question becomes, well, what does this mean to me then? Well, let's say, for example, you got a 95 on a test, or 95 in a class, and you want to figure out what your percentile was. The 95 grade is your A, so I'm just pointing at a 95%. But what rank were you in the class? See, percentile is a rank, where a percentage is just a grade. So it might be a situation where you have a whole bunch of A's in the class, but where were you in that class? Were you in the top 10, the top 5? Were you number 1? So what I have is some hypothetical, here I have some hypothetical Math 101 scores. And I'm going to find the percentiles of A minuses, B minuses, and C minuses. Now, the data is sorted from high to low, and I also want to point out that there are 10 scores that were not put into this data because they were below a D. So there are 30 total scores. So I'm going to put my N equals 30. Even though there are 20 that we can see, there are 10 of them that are below a 60, which is okay because we don't really need to see that. What we do need to see is we need to find the percentile for the A minus. So the question is, what percentile were you in if you had an A minus in the class? So what we're going to do is we're going to count all the values below a 90. So 1, 2, 3, 4, 5, 6, 7, 8, plus the 10 or more that failed. So that makes a total of 8 plus 10, 18. But we have to add a 0.5 to that and divide by our total, 30. If we go 18.5 divided by 30, we get 62%. So let me tell you what this means. In this set of data, this hypothetical set of data, if you earned a 90%, you're in the top 62% of the class, which all of a sudden doesn't make that A minus seem so great, because you were technically almost in the middle. 50% would be the middle. So, maybe you want to shoot for what happens if you were in a B minus, though. So how many scores were below a B, or an 80? Well, that would be 1, 2, and the 10 that failed. So that'd be 12 plus the 0.5 divided by the 30. And this would make, if you type that in, you can pause and type it in, hit enter. This gives you 42%. So now you're pretty happy with that B minus, but in this class, you were below the median. You were below 50%. So you're in the bottom 42% of the class. Or actually just above that 42% mark right there. All right, what about a C minus? Well, how many scores were below a 70? Well, only 1 in the 10 that failed. So this is 11 plus 0.5 divided by 30. Guess what? You're in the 38th percentile. There's 62% of the class higher than you if you earned a C minus. So that is how you would find percentiles. Now, we can reverse the process. On the next page, it says, using the same data, what if you want to say, well, I don't care about my grade. I just want to be in the 70th, 80th, or 90% of the class. Well, to do this, the formula is pretty easy. To find your cut score, or I'll just call it C, C is equal to N times the percentile. This is a little different than the book because I automatically convert from decimals into percents. So what I'm going to do is I want to find out, okay, I want to be in the top 70. So what I'm going to do is find my cut score by going 30, that's my total, times my percentile, 0.70, and this is 21. Now, 21 is not the percent or the cut score. This just tells me 21 scores from the bottom will get me to the 70th percentile. So if I go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, my cut score is 90%. So if I want to be in the top 70% of the class, I am going to get a 90. And if you compare that versus the back page, you can kind of see the correlation there. The correlation because You can see that getting below a 90 was 62. Whoops, sorry. Getting below a 90 at this moment was getting a 62. Well, if you want to get that 90, you would be at the 70th percentile. Okay, now let's look at the 80th percentile. Let's see what I would need there. 30 times 80. If I multiply, or 0.80, excuse me, or 80, or 8/10 if you want to simplify that. This would be 24 scores from the bottom. So this was, if this right here was, whoops, I gotta take this later. A little embarrassing. Alright, so 30 times 0.80 gives me 24, and that 24 right there gives me a cut score of 95%, which means I go from 90, this is 21, 22, 23, 24. 95%. Now, pause the video, and when you come back, you can try to do the 90th percentile and see what your cut score would be. Alright, here we go. This is 30 times 0.90 equals 27. Alright. Oops. I'm going to pause the video here, and then I will be right back for part 2.